Hi, my name is Dured Ahmad,
And my name is Stephen Costigan.
and this is our presentation on the Memento design pattern. The Memento design pattern provides a way for applications to store the data and for later usage by the user. Some applications, like text editors, may require a way for the user to revert the changes they have made. The Memento pattern provides a way for the user to restore that state while preserving the object-oriented principle of encapsulation. The biggest challenge with storing state is the need to capture the internal data. Memento solves the problem using the following four main structures that are also depicted on the right. This image shows the structure of a text editor that stores regularly the state in a snapshot for the user to revert to it if necessary by hitting the undo button. As we can see here, the editor creates a snapshot class or object, which is then stored in the caretaker. The caretaker can interact with each snapshot because each snapshot implements the Memento interface. Another good example would be to think about it in the context of the application that we are trying to build this semester. For example, we can use Memento so that each student can revert the submissions that they have made and set a previously submitted assignment as the main one. So in order to do that, we would need an assignment submissions class, which is responsible for storing the assignment file alongside the date when the student has submitted the assignment. This can be seen in our little pseudocode on the right. For that to work, we also need a snapshot, which is created by the assignment submission class. The main purpose of it is to store that file and the submission date in its internals, and it also has a restore method which sets the main submission and date back into the assignment submissions using a reference that it stores in the snapshot itself.
So now to the benefits or the upsides of using the Memento design pattern. The first thing is that it's easy to implement. One of the great things about Mementos is how easy they are to implement. This is because the Memento object mirrors the originator for file structure, making it easier to create. This also means that when a state is rolled back, the fields that are rolled back directly relate to the fields that are stored. As far as the save state and the undo functionality, Mementos work by saving each change to the state of the program, or snapshot of the program. The snapshot of the program can then be rolled back to a previous snapshot as needed by the user. This is the basis for undo and redo functions used by most modern interfaces. And then as it comes to the security and maintaining encapsulation, as the caretaker is not currently contained within the class of the originator, this means that information stored in each state is kept secure from being read externally. It allows snapshots to be created and restored without making all originator class methods public. Next slide, please. Now for the downsides of the memento pattern, we could have a potentially huge file. As the memento pattern mirrors the size of the originator, the size of the memento can be very large if the originator is large. Each snapshot of the file will also be large if they follow the same pattern, meaning an unmanaged number of states can cause very large files. As far as the memory size, saving states too often can cause the program to consume a lot of memory, which can be problematic. Larger originators will require more memory, and the program can be made slower by this practice. In terms of the obsolete states or the archives, by default, caretakers do not automatically remove obsolete snapshots. Since these states mirror the originator, this can cause file issues spoken of a moment ago with the huge files. The main issue, however, is that many of these may no longer be retraceable and are kept anyway. Many applications will mitigate this by removing states when the program is closed, or removing all prior saved states. Next slide, please. So the recommendations that we might have is that mementos are best employed when the method is more complex or requires multiple stages that might need to be restored, such as with the text editor we spoke of earlier. They can provide fantastic options for reverting changes to a program. Great examples of this are when changing states of a document or image editing program, resizing an object, movements in a game, for example, solitaire, etc. We've all obviously played solitaire where you can go back certain number of moves and so forth, and this would be using this memento design pattern. When a less complicated application is used, the method might be better served by a prototype function, which results to a default state rather than reverting back to multiple saved states. How this might apply to our homework application usage, as we talked about a little bit with submitting assignments and being able to revert back. Track states that would allow us to track states of completion and allow us to users to undo the status change of an assignment, etc., when where such is identified or defined. And that's all we had. Thank you so much for watching.